Good morning, friends. Welcome to this morning session. On the request of some of the people from the audience, I am today speaking on ECG, but I am trying to make it as simple as I can because whereas some technicians, nurses, and some doctors from the non-allopathic field may be benefited, some of the laymen will certainly be benefited who are interested in learning. So I am targeting them also. So what happens when you stand near a pond of water and throw a stone in the water? You have all noticed from childhood to this age that you see water moving in opposite direction, in the direction away from the where the stone was thrown. This is the wave has been set up in water which you see on the surface of the water. Water is not moving, actually it is the wave which is moving. Same applies to the body. When a muscle contracts, it generates electric current, but that is so small that we do not even feel it. But there are machines by which we can augment this charge, and we can augment so much that it can be recorded. So we have special machines by which we can record this machine as it spreads on the body. We can record this current from different positions on the body, from the right arm, from the right side, from the left side, from the left foot, from the chest, all around, going from right to the left side. And they have been by convention given some names. There are 12 leads. Lead 1, 2, 3 are the unipolar limb leads. Lead A, VR, AVL and AVF are augmented unipolar leads, and then there are V2, V6 are the chest leads. Friends, what happens when a muscle contracts and electric current is produced? See here in this diagram. This is the illustration of a muscle being stimulated by giving electric current. Do you see? This is a muscle strip. If you look at this blue inside, blue is the membrane of the cell. Inside you find all negative marked. This is negative charge. Outside this is a positive charge. I will not tell you why inside is negative because that becomes too much complicated. But you are to only know that inside the cell there is a negative charge, outside the cell there is a positive charge. This is the resting position of the cardiac muscle, or we call it resting membrane potential, and in medical terms we call this cell is polarized. See the other diagram. What has happened? We are given a current and result is this. Now see closely, try to make it out. What you find? You find that inside has become negative. See in the black circle. See in the black circle. Inside has become positive, outside has become negative. Opposite of what was present in the resting position. This is called depolarized cell. And here the charge has been created which travels and which we record. Now see this diagram. See this. This is a muscle strip, and here we are giving the current. The wave flows in this direction like this, and here we have kept the electrode. Here is the electrode we have kept. Here is the electrode connected to galvanometer which records deflection like this. But if this is the baseline from where our stylus moves, this goes up and like this. This is above the baseline. This deflection is above the baseline. Remember, the current is flowing, the wave is flowing towards the electrode, and the deflection is above the baseline. That is called positive deflection. See other diagram. Now in this diagram, what do you see? See very closely. Now you see, you give the current here and you have placed the electrode here. the wave is moving like this. So this wave is going away from the electrode. This wave is going away from the electrode. Therefore, it produces a deflection below the baseline, and that is the negative deflection. Any deflection above the baseline, friends, is a positive deflection. Any deflection below the baseline is a negative deflection. Remember, this is the most important point when you look at the ECG. You should immediately say that it has got positive deflection, it has got negative deflection. You will talk of leads, you say that in lead 1 the predominant wave, the major wave is positive, that means it is above the baseline, and in particular lead the major deflection is, or major wave is downward, negative, that means below the baseline. See another diagram to understand it. We said that we kept our electrode away from the source. This is the source, away from the source. Then we kept the electrode near the source here, and this time we are keeping it in between the two. Now what is happening? The direction of the wave is this. So in the first part, up to this part, the current is moving towards the electrode, and therefore that produces a positive wave above the baseline. And then in the rest of the part, it is going away from the electrode. That produces a deflection below the baseline, that is the negative deflection. Now look at this diagram. What do you find? You find that there are two muscle strips, and one is almost more than 2.5 times the other one. Okay, both will, when stimulated, both will produce the charge. Okay, both will make a wave, but a muscle which has more mass will produce a bigger wave than the one which has a smaller one. So what do you see? This is producing a big positive wave upwards, and this is producing a wave which is downward. Now ECG is recorded on a specialized paper. See, I am trying to bring it as close to the screen as possible. See, this is the paper you see. These dark lines, between these two dark lines there are 5 small squares. You see, all these are small squares, and you have 5 marks this way and 5 marks this way, which will make a 25 small squares. Each small square is breadth-wise 0.04 seconds. Breadth-wise it is 0.04 seconds. Here it is shown. Yeah, this is the one where it is shown 0.04 seconds, and 5 such small squares will make it a 0.2 seconds. 5 small squares. You see, this is what we are talking, from here to here. Here it is magnified to make it bigger, from here to here. Okay, this is 0.2 seconds, but single one is 0.04 seconds. And when we count vertically the lines, we find the distance between two lines is 1 millimeter. The distance between the two lines is 1 millimeter. See here, the distance between two lines is 1 millimeter, and naturally in one square it will be 5 millimeter, and in two squares it will be 10 millimeter. Now see this diagram. This is a single complex I have drawn here. See, this is a little violet color, this line, this is a convex upwards. This is called P wave. This is not very tall, it is about 1 millimeter in height above the baseline. It is about 2 to 2.5 small squares from the beginning to the end. This is called P wave of the ECG. Then let me also tell you here that this is the line, this is the line, this is called isoelectric line or baseline. This is the baseline or isoelectric line. Okay, so after P wave deflection, it comes down to the baseline and then goes slightly downwards, then comes back and then goes right up to this end and comes down. This is pointed tall wave is called R wave. This small wave here is called Q wave, and this small wave after the R wave is the S wave. So small wave above before the R wave is Q wave, small wave after the R wave is the S wave. Be very sure about it. This is called together as QRS complex. P wave, QRS complex, and then you have a T wave. Another like P wave, another rounded upwards, convex and bigger wave, that is called T wave. The junction of this S wave with the baseline is called J point, and from here we make the measurements from S point to the T. It is the ST segment. This segment is the ST segment, and from P, end of P to Q, this is QT, PQ segment. This is a PQ segment. But from beginning of P wave to the beginning of Q wave, it is a PR interval. It is actually PQ interval, but it is conventionally said PR interval from the beginning of P wave to the beginning of Q wave. This is very important to know. Another important thing is that from the beginning of Q wave to the end of R wave, this is called QRS complex. And what is the duration of QRS complex? This is also very important in reading the ECG. See another diagram. Here I have shown the segments and intervals. You can see it very clearly and mentioned. I am keeping it for a longer time so that you can also later on also read it and note down. You can stop the video at this point and note down the intervals as it is written in the diagram. Now look at this. This is the first is the which one? This is the P wave. This is the Q wave. This is the R wave. This is the S wave. Do not confuse it. This is the T wave, and in this case this is shown diagrammatically. This is U wave. It is not present in all cases, but when present we have to notice this also. You know that this is the this is the J point, that is the joining of the S wave with the baseline, and from here till the beginning of T wave, this small segment is marked as a ST segment, and from the beginning of the P wave to the beginning of Q wave, this is the PR interval. They are all marked here and you can see them at your convenience. I am keeping the diagram here for some time so that you can make a note of the thing. Now we record ECG from 12 positions, and these 12 positions are little difficult for non-doctors to understand. We have bipolar electrodes, or we call them bipolar limb leads. This is between the right arm and left arm, between the left arm and left leg, and between the right arm and left leg. So we have 3 limb leads. These are called standard limb leads, or limb leads as such. Then we have unipolar limb leads, but they are augmented. They are called unipolar augmented unipolar limb leads, and they are denoted by small a for augmented. Now, then we place leads on the chest and we record them from the chest. The V1, see this diagram, see V1 here, V1 is here, V2, V3, V4, this is the V6, this is the V6. Now V1 lead, this one, V1 lead is placed in the right parasternal region, fourth intercostal space. So fourth intercostal space in the parasternal region, we place a lead. This is the chest lead V1. Then on the left side, on similar position, that is the left parasternal region, fourth intercostal space, this is the lead V2. Then we go to the lead V4. This will be in the fifth intercostal space in the mid-clavicular line. Fifth intercostal space, mid-clavicular line, that is the place where we place the lead V4. And lead 3 comes midway between the lead V2 and V4. Then we have the armpit, we have anterior axillary fold, we call it, the muscle you can feel in your armpit by in the form of fist. This is the V5, and then in the middle of the axilla or middle of the armpit you have lead V6. So friends, that is what the ECG is. Reading ECG is a really difficult thing, and that is where you require a lot of practice. When used to teach these students, I divided them into batches of 4 or 5 students each. I used to give them the ECGs of the patients which I had kept as a record and asked them to write a full report of ECG. I used to tell them that do not make diagnosis. You simply write the report how it should be written. And this I will tell you in another lecture how the report is written. Thank you very much for today. Is sufficient. Friends, do like, comment and subscribe if you have not done it as yet. And do press the bell button so that you get the intimation for our next lecture. If you have any suggestions, you are most welcome to give it to us. But do not forget to comment on because that tells me how and where I should improve for your benefit. Thank you very much. See you in the next lecture.